Okay, math box is 5.8, lesson 5.8. Going to move through these a little bit faster. 6 boxes of gumballs spilled onto the floor. Bonnie picked up enough. Alright, today we're going to be looking at math boxes 5.8 on page 172. 6 boxes of gumballs spilled onto the floor. Bonnie picked up enough to fill 2 1/6 boxes. Carl picked up 2 2/6 boxes, and Betty picked up 1 2/6 boxes. How many boxes of gumballs did they pick up? So we're looking for a total here of the 3 of them. And again, I'm going to start with my whole numbers. This time I'll tower them. So 2 1/6 for Bonnie, 2 2/6 for Carl, and Betty had 1 2/6. And we're adding all 3 of those together, and so my sixths as a fraction, I have 2, 4, 5, and my whole number 5 altogether, and nothing to carry over or change because this is an appropriate mixed number. So I can say 5 5/6. Over here, draw 2 rays with the same endpoint. Label the endpoint E. Label a point on each of the rays. Okay, so they're going to have the same endpoint. I'm going to choose that to be their endpoint, and I will label that E. And since they are rays, they go from the endpoint and out in any direction. And to label another point on each ray, all I have to do is put 2 points, and I can give them any letters I choose. Let's give this one an R and this one a D. Name one ray. So one ray would be ER. ER, and give it the ray symbol. Name another ray. So I've named ER, the other is ED. ED, and it is a ray. Name the shape the 2 rays make. So in this case, I've chosen to use an acute angle. Okay. Number 3. A lamp at Benson's Lighting costs $26 less than the same $203 lamp at Lights and More. If Jeremy buys a lamp at Benson's along with light bulbs for $18, how much change will he receive from $200? Okay, so a lamp at Benson's Lighting costs $26 less than the same $203 lamp at Lights. So at Lights it costs $203, but at Benson's we don't know the cost, but we know that it's $26 less than at Lights. So here we're going to subtract. Let's regroup, and I'm going to just make that 20 into a 19. Since there was a 0 there, that's one way I can regroup. And that 13 minus 6 is 7. 9 minus 2 is 7. And 1 minus 0, oops, that's what erasers are for, folks. 1 minus 0 is 1. So the cost of the lamp at Benson's we now know to be $177. And he bought light bulbs for $18. So now I'm going to add to the 177. Okay, and there's 15, carry 1, 7, 8, 9, and $195. And so if he spent 200, excuse me, if he had 200 and he spent 195, again, I can borrow from that 20, make it a 19, and this becomes a 10. There's 5, 0, and 0. So his answer, make sure we're answering the question, how much change did he receive? And yes, the answer was $5. Okay, over here it says circle the fractions that are not equivalent. So circle a fraction that is not equivalent. I'm assuming that means one in each set will be not equivalent. So 2/10 is not equivalent to 3/6 because 3/6 is 1/2. Okay, and 2 out of 10 is not half, 1 out of 5 is not half, and 2 out of 20, or excuse me, 20 out of 100 is not half. So I know right now the one that's a half is the one that's not equivalent. Here we've got 3/5, 2/4, 4/8, 1/2. Now this time I do see 3 that are all representing 1/2, 2 over 4, 4 out of 8, 1 out of 2, 1/2. So that means 3/5 is not equivalent. Down here I go to 3 out of 12, 1 out of 8, 3 out of 10, 1 out of 4. Well, first of all, I can look at these multiples here, 4, 8, 12. So let's see, 4 times 2 is 8, 1 times 2 is 2, so these two are equivalent. And 4 times 3 is 12, and 1 times 3 is 3, so that is equivalent to 1/4, and that means this one must not be. And again, over here, ooh, okay, I've got 3, 6, 12, and 8. If I can see these have a commonality here, 3, 6, 9, 12. Okay, 8 looks like my odd man out, but let's see, 1/3. Well, 3 times 2 is 6, 1 times 2 is 2, so these two are equivalent. 3 times 4 is 12, 1 times 4 is 4, so these two are equivalent, which means this one must be the odd one out. And again, I'm asked to add some fractions here that do not have a common denominator, but I can do that pretty easy because I know that 4 100ths, I can make it have a common denominator of 100 because 9/10 is 90 hundredths. Multiply the top times 10 and the bottom times 10, I get an equivalent fraction, and that just gives me an answer of 94 hundredths, and that means C would be my best answer. And finally, what can I do to make the number sentences true? So I'm looking at place value, and I'm just concerned about the highest place value that is different, because that's going to tell me whether it's less than, greater than, or equal to. Okay, so here in the ones place, I have a 7 for both numbers. In the tenths place, I have an 8 here and a 9 here, and 9 is greater than 8, even though this has a 9 after it. 9 tenths is always going to be greater than 8 tenths and any part of 100th. 4 in the ones, 5 here in the tenths, 0 here in the tenths, so this one is greater. 0 in the ones place, 6 in the tenths place, and actually a 0 here. I had written that 0 earlier. I'll take it out for a second just to show you. Okay, so here we have 6 tenths. I'm going to write that out. 6 tenths and 60 hundredths is the other one. Okay, but again, those are equivalent fractions, because if we multiply the top and the bottom by 10 over 10, which is 1 whole, I get 60 over 100, so those are equivalent. And last, 9 in the ones place, 8 in the ones place, 9 is greater than 8. And there we have Math Boxes 5.8.